Okay, so our null hypothesis is that the mean number of TV hours watched by men minus the mean number of hours of TV watched by females equals 0, and our alternative hypothesis is that it does not equal 0. So we go into the data table. First we have to see if the data is normally distributed. So we put the gender in the by variable and television in the response variable. That's the number of hours watched of TV. We can stack it, and we need to go to continuous fit and normal, and then fit and normal and goodness of fit. And when we do that for both, we see that we get a p-value of less than, or a p-value of 0.01, which means that the data is not normally distributed, and that's the same for both of them. So we have to be careful because our approximations could be off. And then when we go into the fit y by x module for the EDA, we put television response gender in the x factor. We need to check the display options and add histograms, and also points jittered, and mean lines, and box plots. And we see that the box plots are pretty similar, the histograms are pretty similar, and when we compare the densities, they're also pretty similar. So we're not sure about the variance. They could be the same. Also, means and standard deviation. The standard deviation is a little different. So then we go to the equal variance test, and we get a p-value of less than 0.0001, so they're not equal variances. And then, so that means that we use the t-test to analyze the means. And when we check that, we find that the probability of the alternative hypothesis that they're not equal is less than 0.001. So we can conclude that with that p-value, we can reject the null hypothesis and conclude that the mean difference between the number of hours watched by men and women is not 0. And with this, with the confidence interval given to us in the t-test, 27.2155 to 32.0259, we can assume that men watch more TV than women do.